Hi friends, welcome to my video. Today in this video, I will discuss about the nameplate detail of air circuit breaker. Whatever information available at the front face of air circuit breaker, we will discuss each of them in detail. In this video, we will discuss about the off button, second on button, third will be main contact position indicator, fourth energy storage mechanism, status indicator, fifth reset button, sixth LED indicator, seven Micrologic controller, 8 connection test and isolated position stopper, 9 user supplied padlock, 10 connection test and separation of the position indicator, 11 connection separation and test position indication contact, rated nameplate, digital display, mechanical energy storage handle, sec input output, rack out handle and fault trip reset button. In this video we will discuss all of them. So let's start. What is off button? You can see the one here, the red color, and the letter mentioned on the red color button O is a off button. With this we can turn the breaker off. On button, this blue color button of the ACB in which the I letter is mentioned is the on button of ACB. By pressing this button we can on the ACB. Third one is main contact position indicator. You can see here either ACB is written on or off. To understand the status of the main contact, that it is closed or open. If the ACB is on, then here mention on, and if the ACB is off, then here the status will reflect off. So from this indicator you can check that ACB is either on or off. Fourth one is energy storage mechanism status indicator. What is this? Here you will see spring is charge or discharge. Now let us understand what is spring charge and discharge. As we know that ACB is handling very high current. Generally ACB is coming from 800 ampere to 10,000 ampere, which is very high current. So it is very important that during making and breaking the circuit, moving contact should make and break the contact with the fixed contact of the ACB in fraction of second in order to reduce the arc formation within the air circuit breaker. This spring will give that potential energy to the moving contact so that moving contact can make and break the contact with the fixed contact within a fraction of second. So the purpose of spring charge is to make and break the circuit in fraction of second in order to reduce the arc formation within the air circuit breaker. So this indication will give that the spring is charged or discharged. If the spring is discharged, we need to charge this spring by using this handle, or sometime there is a DC motor inside the ACB to charge it automatically. The fifth one is test button. The simple use of test button is to know that there is a voltage in the air circuit breaker or no. The sixth one is LED indicator. These are the LED indicator. It will show on which fault this ACB has been tripped. If ACB is tripped under overload condition, then the overload indication will glow, and if the ACB is tripped due to the short circuit fault, then the short circuit fault indication will glow, and if the ACB is tripped due to the ground fault, then the ground fault indication will glow. So these are the indication which indicate us that under which fault the ACB has been tripped. The next detail available on the air circuit breaker is a Micrologic controller. These Micrologic controller dial give us facility to set our air circuit breaker as per the load requirement or as per the load characteristic which is connected on that ACB. There are total 4 settings on a Micrological controller: long time setting, short time setting, instantaneous current setting, and ground fault setting. You can see here long time setting, short time setting, instantaneous setting, and the ground fault setting. So let us discuss one by one to understand this setting of a circuit breaker. This is the very important part of this video. The long time setting gives protection against the overload. But before to understand long time setting, we need to understand what is nominal current and what is rated current. Here in our example, you can see IN is equal to 4000 ampere. The IN is here the nominal current. What does nominal current mean? This is the maximum value of current that the circuit breaker can carry without tripping an overcurrent relay. Means this breaker can maximum carry 4000 ampere of current. What is IR? IR is the rated current. This is the maximum current that the circuit breaker can carry after adjusting the overload tripping setting. This setting depends on the load current requirement. What does it mean? It means that the maximum current that this circuit breaker can process for the normal operation when the overcurrent tripping setting is adjusted. Let me give you an example to better understand the difference between the nominal current and the rated current. Suppose this air circuit breaker have a nominal current of 1000 ampere. Just for a simplicity, I am taking a easy numeric value. Suppose I have a air circuit breaker and the nominal current is 1000 ampere, and if we adjusted this dial on 1, then our IR will be, as per here, IR is a multiple of IN. IR will be 1 into what is the nominal current, 1000. So our IR value will be 1000 ampere. In this case, the nominal current of the circuit breaker and the rated current of the circuit breaker is same. But when we adjusted this dial to 0.8, for example, let us consider that this dial is adjusted on 0.8, then IR will be 0.8 into 1000. So what would be the value? 800. So the nominal rating of this breaker is 1000 ampere, but the rated current rating of this circuit breaker is 800 ampere. And suppose if the dial is adjusted on 0.4, then the IR value will be 0.4 into 1000. So what would be the value? 400 ampere. In same way, if we will adjust the dial on 0.5, then the rated current of this air circuit breaker will be 500 ampere. In same way for 6, if we will adjust on 0.6, it will be of 600 ampere. If the dial will be adjusted on 0.7, then the rated current of this circuit breaker will be 700 ampere. Here you can notice that we can change the 1000 ampere breaker to 400 ampere by changing the dial to 0.4. In same way, we can change this 1000 ampere breaker to 500, to 600, to 700, to 800, to 900, to 950, to 980 and 2000 ampere by adjusting this overload tripping dial. So we can change the rating of the breaker at least to the 40% of the nominal rating to the maximum 100% of the nominal rating of the breaker. Now let me explain you why it is important or required to change the ampere rating of the circuit breaker. Suppose I have a load which can carry a maximum 800 ampere of current. Okay, and this is fed by this circuit breaker of 1000 ampere nominal current rating. For this circuit breaker, the overload condition will be when there is a more than 1000 ampere current is flowing through this circuit breaker. But for the load which is connected from this circuit breaker, have a overload condition when any current flows through this load more than 800 ampere. When a current of 850 ampere will flow through this load, then the circuit breaker will not trip. Why? Because for the circuit breaker, the overload current condition is after 1000 ampere. Then what will happen? The load will break down. But when we change the over tripping setting to 0.08, then the ampere rating of this current will become 0.8 into 1000, which will be 800 ampere. So in that case, we will meet our load requirement. As I told you also, this rated current IR is depend on the load requirement. Okay, but maybe you will have a question in your mind, then why we will not directly go to the 800 ampere of air circuit breaker to feed this load? Yes, it is very true. But suppose if we added 100 ampere of load to this network or to this air circuit breaker, then we have to replace this circuit breaker, because this circuit breaker which you choose in 800 ampere is now no more capable to handle 900 ampere of load. And suppose another example, suppose we reduce the load from 800 to 700 ampere, then this circuit breaker have a 800 ampere rating. For the overload condition for this circuit breaker will be 800 ampere, but for the load which we have connected with this circuit breaker have a overload condition after 700 ampere of current. So again we have to change the circuit breaker. To avoid changing of the circuit breaker due to the small changes in the load, manufacturer giving this overload tripping setting to set your air circuit breaker depending on your load. Now let me discuss what is TR, long time delay setting. To understand this topic, let me take an example. Suppose this circuit breaker is feeding an induction motor, and as we know that induction motor during starting taking high inrush current, and after some time it is taking only the full load current, and at the time of starting the high inrush current might be 4 to 5 times higher than the full load current, or we can say that the starting current will be 4 to 5 times of full load current. Suppose this air circuit breaker have a nominal current rating of 1000 ampere and the motor have a full load current rating as 800 ampere. So we set this dial to 0.8 to change this breaker rating from 1000 ampere to 800 ampere. Now at the time of starting, this motor will take a huge current which is called a high inrush current due to starting of the motor. Let's say this motor having a star delta connection, so it will take during starting it will take 3 times of the full load current, then it will be 2400 ampere of current. But as we set this dial on 0.8, so the current rating of this breaker is only 800 ampere. So this breaker will trip because at the time of starting 2400 ampere of current is flowing. But this tripping will be undesired tripping. Why? Because this starting current is temporary. It will only for few seconds, maybe for 3 or 4 seconds. After that one, this motor will take only the 800 ampere full load current. Or if there is a not much load in this motor, then it will take less than 800 ampere of current. So at the time of starting, this breaker is tripping because at the time of starting a huge current, that is in our case for 2400 ampere of current is flowing through this breaker, so it will trip. But this tripping is undesirable. Okay, we have to stop this tripping. So what we will do? We will give some time delay, and in that time delay, if that current will pass, then this breaker will not trip. So in our example, we give that the 6 time of IR, the 6 time the load, what is load current? 800 ampere. The 6 time will be 3200 ampere of current. If there is a 6 time of full load current is flowing through the circuit breaker for 12 seconds, then this circuit breaker will not trip, but it will trip when this more than this current will flow for more than 12 seconds. So in that way we will control the undesirable tripping of the circuit breaker by giving the delay. I hope you understand what is nominal current, what is rated current, and what is long time delay setting, and why these settings are required in the air circuit breaker. Now let us move forward to the other setting, which is short time setting, ISD. The previous one is the long time setting, as I told you, and the long time setting is for overload protection. The next topic is the short time setting, which is for short circuit protection. Suppose there is a short circuit fault in the load which is connected by this air circuit breaker, then there will be huge current due to short circuit fault. This short time setting will facilitate that how much short circuit current will be allowed and for how much time. We can define or we can set it by this setting. Suppose this is a 1000 ampere circuit breaker. This 1000 ampere I am taking for simple numeric calculation. It can be anything: 2000, 1000, 800, 1600, 2500, anything, but I'm taking 1000 ampere to have a clear numeric understanding. Now suppose this circuit breaker having a nominal current rating of 1000 ampere. We set it to 0.8, then the IR will be 800 ampere, which I explained you earlier. Now we need to set now the short circuit fault rating. How much short circuit fault current will be allowed through this circuit breaker and for how much time. This we need to set. Suppose we set it at 0.2, then the ISD will be 2 times of IR. What is our IR? 800. So it will be 1600 ampere. Short circuit fault current is always a severe current. So the time setting is for very short duration. Here you can see 0.2 seconds, 0.3 seconds, 0.4 seconds. So we can set it to 0.2 second, 0.3 second and 0.4 second. So this circuit breaker will trip when there is a 1600 ampere of current. If the dial is on 0.2 second, then it will hold the tripping of the circuit breaker till 0.2 second. But if there is a short circuit current more than 1600 ampere, then this circuit will trip it after 0.2 second. If the dial is in 0.3, then it will hold this short circuit current till 0.3 second and it will not let the circuit breaker to trip. But when this current will cross beyond 0.3 second, then it will trip the breaker. Here you can see there is a black portion. In that there is a 0.1, 0.2, 0.3, 0.4, which is in the on section, and there is a white section. Here also there is the same setting: 0, 0.1, 0.2, 0.3 and 0.4 in the off section. What does it indicate? In the on section, it will take the action to trip the circuit or to trip the breaker. But in off section, this breaker will not take the action to trip the circuit breaker. It will give only the alarm for the short circuit fault. So here in our setting, it is in the on side. So when there is a short circuit current of 1600 ampere as per our example, for more than 2 seconds, this circuit breaker will trip it under the short circuit fault condition. Now let us move further. The instantaneous current setting. There is a small difference in the short circuit current setting and the instantaneous current setting. The short circuit fault setting is taking a small time, that can be a 1 millisecond or 2 millisecond or 3 millisecond, but instantaneous current, which is very huge current, more than the short circuit current and taking no time to reach that current, then there is a setting for this to trip the circuit breaker at the instantaneous current fault. This can be due to the line surge or any huge fault in the network. So suppose we have a ampere rating, nominal ampere rating of this circuit breaker 1000 ampere. Okay, then if we will set it to at 6, then the instantaneous setting will be 6 times of nominal current. Okay, so it will be 6000 ampere. So if this circuit breaker detect that there is a huge current within no time, then it will consider it is an instantaneous fault and it will trip the circuit without taking any time. That's why there is no time setting for the instantaneous fault. Hope I'm clear now. Now let us discuss about the ground fault setting. The ground fault means if any one or more than one phase is contacted with the earth then or to the ground, then it is called ground fault. So there is a setting for the ground fault also. The knob have a arrow which will be either can be set on A, B, C, D, E, F, G, H and J. And there is a time delay also for the ground setting which can be set on 0.1 second, 0.2 second, 0.3 second and 0.4 second. And as I explained you in the short circuit time setting, there is a black shade and there is a white shade. Black shade is a on position and white shade is a off position. So when the dial is in the on side position, then it will trip the air circuit breaker, and if the dial setting is in the white shade, then it will only give the alarm but it will not trip the air circuit breaker. Now suppose if the dial is on A, then this circuit breaker will trip when there is a 20% of the nominal current rating flowing into the ground. So in our case, suppose there is a 1000 ampere nominal current, then what would be the A value? 20% of 1000 ampere. So it will be 200 ampere, right? 200, when 200 ampere of current is flowing to the ground, then this circuit breaker will trip. In same way, there is a different values for B, C, D, E, F and till J. So, but it varies from 20% to 70%. Okay, we can set it maximum till 70% of the nominal current. The ground fault setting is very important and useful for coordinating between the circuit breaker. Suppose there is a 3 circuit breaker A, B and C. A is feeding B and C circuit breaker. We set the ground fault time setting as 0.02 second, and for the outgoing feeders we set the ground fault time delay setting as 0.1 second for B and C. Suppose if there is a ground fault for the circuit which is feeded by B circuit, then it will trip the B circuit because the time delay is 0.1 second, and once it trips there will be no ground fault because this hole will be disconnected from the circuit A. So this type of arrangement, by using this type of arrangement, we can give the priorities to the downstream and upstream circuit breaker to trip. So this ground setting is very helpful in coordinating between the upstream circuit breaker and downstream circuit breaker. Hope I'm clear with you. Hope you clearly understand the micrological controller setting, that is long time setting, short time setting, instantaneous current setting and ground fault setting. Now let us move to our next detail which is present on the air circuit breaker is connection, test and isolated position stopper. I will explain this one after explaining point 10, that is connection, test and separation of the position indicator. Here you can see this is the position indicator which will indicate that the circuit breaker is in the connection position or is in the test position or is in the separation position. When we will rack out the circuit breaker, then it will come first to the test point, test indicator, and then it will come, when we will keep on racking out the circuit breaker, then it will come to the separation indicator. In separation indicator we will completely rack out the circuit breaker, and this will be for maybe for the maintenance purpose of the circuit breaker. When the pointer indicating connection, then it means circuit breaker is completely connected with the network and it is ready for the energization. And if the pointer indicating the test, it means the circuit breaker is under testing condition. And when the pointer indicating separation, then it means the circuit breaker is completely racked out and it can be sent for for any maintenance if required. Okay, so here I left this point 8 topic, connection test and isolated position stopper. This one is the position stopper, means whatever be the position like connection, test or separation, this stopper will stop the circuit breaker in that position. Okay, now let us move to the topic number 9, that is user supplied padlock. This is the user supplied padlock. When we will remove this one and we will lock it, then if anyone come and press this on button, it will not work because this circuit breaker is locked. Why it is important? Because someone is doing some maintenance on the circuit which is fed by this air circuit breaker, and he is touching the live parts because he is doing the maintenance. Then if someone will come and on this circuit breaker, then it will be a high risk for the person who is maintaining that circuit. So what the guidance is that that maintenance guy will come and lock this circuit breaker. So if anyone come and try to open this circuit breaker by pressing this I button, it will not be active because there is a padlock in the circuit breaker, and the key of that padlock will be with the same guy who is maintaining the circuit. So this is for the safety reason. Now let us move further to our topic, that is the rated nameplate. This is also a very important topic, same like a Micrologic controller. The first detail available on the rated nameplate is UE. UE is a rated operating voltage. It is a continuous operation voltage for which the circuit breaker is designed. So this UE voltage is a operational voltage for that circuit breaker, and this voltage will be nearby the system voltage like 415 volt, 440 volt, 430 volt. So here you can see the operating voltage for this circuit breaker for 3 phase is 440 and for single phase is 220. Okay, now let us understand what is UI. UI is a rated insulated voltage. UI is a rated insulated voltage. It is a maximum voltage that the circuit breaker can resist according to laboratory test. Means UE is a normal operating voltage of that circuit breaker, and UI is a voltage at which the circuit breaker is being tested in the laboratory. So always the UI is greater than UE because UE is the normal operating voltage and UI is a testing voltage at laboratory. Okay, now come to Uimp, like we can say it U impulse. This is the rated impulse withstand voltage. Rated impulse withstand voltage. What does it mean? It is a value of transient peak voltage the circuit breaker can withstand from switching surge or lightning strike imposed on the supply. Suppose this circuit breaker is connected with the network and there is a lightning surge on that network. Due to this lightning surge or switching surge in the network, there will be a huge voltage across this circuit breaker. Okay, suppose for this breaker the U impulsive is 12 kilovolt. It means this voltage, this breaker will withstand for this lightning surge or switching surge up to 12 kilovolt. Now let us discuss the other rating available on the rated nameplate of circuit breaker, which is ICU, ICS and ICW. Here it is mentioned ICU, ICS and ICS and ICW. These all are short circuit breaking capacity of circuit breaker, but there is a difference in all these current. Let us understand what are the difference and what this current stand for. ICU means it is a ultimate breaking capacity of the circuit breaker. What does it mean? Suppose this circuit breaker is first on, okay, then off it, again on it, and we will do this operation 2 times when there is a short circuit fault in the circuit breaker. And then we will see that this circuit breaker is operational, and we will again give the operational voltage to this circuit breaker. And if this circuit breaker withstand this operation, that is, there is a fault in the short circuit fault in the circuit breaker, and we on it, then we off it, and then again we on it, and this operation we will do 2 times, then, and if this circuit breaker will withstand and break that short circuit fault current, then this rating will be called ICU, that is the ultimate breaking capacity of the circuit breaker. Now let us discuss about the ICS. ICS is nothing but the service breaking capacity or service short circuit breaking capacity. How to get this ICS rating of the circuit breaker and how it is different from the ICU? Let us understand in further discussion. Suppose there is a circuit breaker and we on it, there is a circuit breaker and there is a short circuit fault in the network. We on the circuit breaker, then we turn off the circuit breaker, again we on the circuit breaker. And if we will do this sequence 3 times, and after doing this sequence 3 times, during there is a short circuit fault in the system, then we will see that the breaker is operational or not. Then we will say that is ICS rating of the breaker. Now let us discuss about ICW. ICW is nothing but short circuit withstand capacity. Let us understand what does it mean. Suppose the circuit breaker is operational and it is operating in normal condition, and suppose there is some short circuit fault happen at the circuit. During this circuit is feeding the normal operation. Due to the short circuit fault in the network, there will be huge current through the air circuit breaker. ICW is the maximum short circuit current that a circuit breaker can withstand for some interval of time when the circuit breaker was operational. In short, ICW, short circuit withstand capacity, is the maximum capacity of a circuit breaker when there is a all of sudden short circuit fault happen when the air circuit breaker is feeding the circuit normally. So hope I am clear what is ICU, what is ICS, and what is ICW. In our example, let us see. ICU is 50 kilo ampere. It means this breaker can withstand up to 50 kilo ampere of short circuit current when there is on, off and on operation for twice, when there is a short circuit fault in the circuit. ICS is a 100% of ICU, means the ICS is also 50 kilo ampere because it's 100%. Why the ICS is expressed in the percentage of ICU? Because suppose during the ICS testing operation, we turn on the breaker, turn off the breaker, and again turn on the breaker 3 times when there is a short circuit fault, then it might be the 70% of the ICU, or it might be the 80% of the ICU rating, but the best isolator will be the 100% of the ICU. Means after conducting 3 times that sequence, the ICS rating is same as the ICU rating. That is why the ICS rating is given in 100% of ICU or in the percentage of ICU. Here in our example, the ICW is 50 kilo ampere for 1 second. It means when the circuit is feeding normally and there is a short circuit fault all of a sudden in the circuit, then this circuit breaker withstand till 50 kilo ampere of short circuit current for 1 second. Now let us move further for our next detail present in the air circuit breaker, that is the digital display. This is the digital display. Here you can see what is the line to line current, line to line voltage, and what is the line 1 current, line 2 current, line 3 current, what is the power factor, and many more things you can see here. and for that there is a menu button also and left right button also. From there you can change and select the menu to find these values which I told you. The next detail which is present in the air circuit breaker is mechanical energy storage handle. This is the mechanical energy storage handle. With the help of this we can charge the spring, and I told you previously why we need to charge the spring. Okay. The next is sac. Sac is this slot. When we will remove this rack out handle and we will put in this and we will rotate this handle, then this ACB will rack in and rack out. So this is sac. Rack out handle. This is the slot for the rack out handle, and when we will remove from this slot the rack out handle, it will look like this. The purpose of this handle is to rack in and rack out the air circuit breaker. The 17th detail is fault trip reset button. This is the fault trip reset button. Suppose due to the overload current or due to the short circuit current or due to the instantaneous current or due to the ground fault, there is a trip in the air circuit breaker. So we can reset that fault by pressing this reset key or reset button in the circuit breaker. This is all about the detail present on the air circuit breaker. I hope if you watch this video till end, then you will get everything related to the air circuit breaker nameplate. Hope you find my video very informative. If you really like my video, then please give thumbs up and subscribe to my channel. We will meet in any other video. Till then, take care, keep learning, and bye bye. Thank you so much.